I got is the final exam. I will be working on it in the next 24 hours, and you'll be get to see it'll come up. It'll say Hubert's final exam, and that'll be your exam. I don't think I'm going to go over 25 questions because of some of the, you have to integrate or take the derivative, and sometimes that takes a little bit of time. So I think I'm going to keep it around 25 questions. Is that okay with everyone, or do y'all want me to make it 50 questions? I'll be glad to do whatever they,
What's the time
What?
again?
Say again?
How much time do we get to take it again?
2 hours. I'm not going to make it over 50 minutes.
I prefer more questions.
You do?
I really detest it when they give like 4, 10, 25 questions for a massive final.
Okay, so 33 questions. Is that a little bit better? Because I can't
First part.
I can't give y'all 50 questions because I don't think you'll be able to finish it.
Then why'd you ask?
I can give you 33.
Nah, 25.
25.
Y'all making it worse on me now.
Hey guys, what's funnier than 24?
SpongeBob. Oh, that's one of my favorites.
My only question is, what's the percentage that the final's worth?
It's the same as your test.
Okay.
All of them are 80%. So if you've got 5 unit tests or 4 unit tests and the final, each one of them's worth 20% of the 80% for the final. You'll see that on your when you do your calculation. If you show calculation on your grade book, all the unit tests will equal 80% of the grade. So you take your average, multiply that by 0.8, and that's your test average. And then you take your homework, which everybody should make 100 on your homework, especially since I've given you till midnight tonight to fill in all the blanks. Everybody should turn in a homework grade of 100, which is 20 points. So you'd add 20 points to whatever that is if you did all your homework. Does that make sense, Mr. O'Quinn?
Yes.
Okay.
I just didn't know if it was going to be like 15% and then subtract that from the 80%. Yeah, it's a whole.
Yeah. Yeah, it's the 80 and 20. And I did go through and put, and I don't know if y'all realize this or not, but I did go through and put 1% on 5.1 and 5.2. So I gave your other chapter 5, I think I made, 5.1 and 5.2. I put 1% instead of 4%. Each one of the homeworks throughout the semester is about 4% of the 20%. So the 1% is not going to affect you. If you didn't do 5.1 and 5.2, all the questions, it's not going to hurt you. It's only 1% of 20%, if that makes sense. So anyway, let's move on. Okay, the first, let's see, let's go to, I'm going to go to the email. And I went through and picked out some questions, and I'm going to try to hit as many as I can. This one is a test question, and I thought I would pull it up first. This is find the critical points of the following function, and that is a test question. So write that one down. And I'm going to, I got to find it. There it is. I'll try to find a happy medium between the 25 and the 33, okay? I'll do something. Maybe I'll just make it 30 even. But I'll have to watch, because when I make out a test, each question has an average time based on MyLabs Plus all their input, all their statistics that comes in. So I may have, one question at 3 minutes and one question is 5 minutes. So I try to make my test around 50 minutes to 60 minutes. That way I give everybody an hour and a half. I give everybody an extra, I think, 40 minutes to do the test. So you should be able to do it. I'll still make it 50 minutes. Okay, so this one says, and I'm going to bring in my handy dandy, make it smaller. Okay, find the critical points. Now with the first derivative, they just want the first derivative. The first derivative, you're just finding the increasing and decreasing. So with that being said, f of x is equal to 4x cubed minus 23 over 2 x squared plus 5x. The only thing I'm going to do is go ahead and take the derivative. I might pull that 23 over 2 out a little bit, but that's going to be what? 3 times 4 is 12. That's 12x squared.
23.
And then this is going to be minus 23 over 2 times 2 over 1. X to the 2 minus 1 is 1 plus 5. And now I take my handy dandy red pen, take that out, and f prime of x is equal to 12x squared minus 23x plus 5, and that is going to tell you about increasing and decreasing values. So set that equal to 0. And this is going to tell us our increasing and decreasing values. Now it's going to give us our critical points to check on the number line. So with that being said, go ahead and I'm going to complete the square just to piss y'all off. 12x squared minus 23x plus blank is equal to 0. Oh, I got to bring the 5 over. That'd be what? Negative 5? Negative 5 plus blank. Factor out of 12. That's going to be x squared minus 23 twelfths x plus blank is equal to negative 5 plus 12 times blank. Now I'm going to do a baby step here because I got to remind y'all how to do the complete the square. You got to factor that 12 out first, and now you can take this and divide it by 2. So that's 23 over 12 divided by 2 over 1, and you're going to square it. So that's 23 over 12 multiplied by 1 over 2, square it, and that's 23 over 24, square it, and that should be 529, y'all check me, over 576. So that's 529 over 576. 529 over 576. Okay, now that's shortcut number 2. So
Yeah,
I'm going to go to the next page. Say again?
Factor by grouping would have been easier.
It would? Okay. Well, I like complete the square, so we're going to complete the square, and then I'll go back and do it by the other way. And then that will give us 12 times x minus 23 over 24. Quantity squared is equal to, and you can change that to, you can see of the 12, or you could just go ahead and do the math. And I did it as a decimal, and that's going to come out to be 6.02. I just got rid of all those big numbers and just got down to 6.02. And then take this, divide by 12. X minus 23 over 24 quantity squared is equal to, I got 0.5017, and then bring the 23, or take the square root, and that's going to be X minus 23 over 24 is equal to positive or negative 0.7083. And then change that, use the 23 over 24, bring it over as a plus 23 over 24. And X is going to be 1.67 and 0.25. That is your critical points. And if you break it up by reverse FOIL, you can do that also. However you want to do it, you should come up with the same answer. So if you break it up into reverse FOIL, I believe you said that was what you did, Mr. O'Quinn?
Factor by grouping.
Factor by grouping.
Yeah, 12x squared minus 20x minus 3x plus 5. And then factor that out and then factor it again. 3 steps.
I wonder, did you try reverse FOIL?
I had not.
I wonder if that would work. Let's see. 12x squared minus 23x plus 5. 1 and 5. 1, 12, 2, 6, 3, 4. That's a pretty big number. So 3 here. 3, that'd be 15, and 4, that wouldn't work. 4 here would be 20. That's it. 4x and 3x. And you need a negative, so therefore the 20's got to be, and that, y'all check that. 4x minus 1 is equal to 0. 3x minus 5 is equal to 0. Y'all check me. 4x is equal to 1, 1/4. And x is equal to 5/3. Somebody divide 3 into 5 and see if you get 1.67. So you can do it, I think you can do it by reverse FOIL. Pronounce it however you'd like.
Yeah, 1.6 repeating.
Okay. So that you can do it by completing the square or reverse FOIL. Now remember, that gives you the increasing and decreasing values. If you take the second derivative, which back here, here's the first derivative. If you take the second derivative, f double prime of x is equal to what? 24x minus 23. And set that equal to 0. That will tell you where the concave up and the concave down is. And the critical value here is equal to what point? The inflection point. Or inflection point, if you leave out the L, right, Ms. Hart? Okay. So your critical point here, when you do the second derivative, if you have to on the test or homework question, if you take the second derivative and set it equal to 0, that's going to give you the point at x that will be the inflection point. Plug it back into the equation to get the y, and you got your point where the concave up and the concave down separate. Good question. I can't remember who sent it, but that was a good one. Okay, the next question I had, or to go through, is, that's that one. That's 27. I can get rid of that one. This one, excuse me. Oh, this one, Rona, this one I think is on the test. And I like this question, but I couldn't find any more like it. This is the only question I could find like this.
That one was a pain.
It's not a pain. It's just you have to look at the graph. And some of y'all don't like to do that.
It's not even that. It's just the way that they wanted it written was a pain. Right? Like doing it was easy, but the way the program wants you to write it in the notation's a pain.
Well, I tell students that when you're talking about increasing and decreasing values, you got to think of a plane. And let's say my cursor is a plane. And that plane is coming up. Of course, that blue function is coming up, it's coming up, it's coming up, it's coming up. And at each vertex is where the plane is going to change direction. Now, when you're talking about increasing and decreasing values, and this is an algebra problem. This is really not a calculus problem. It may be talking about first, second derivative, but the actual graph it's just a plain old algebra problem. Increasing and decreasing values. Are in terms of X. Okay. Now the problem that students have is they want to say increasing and decreasing values are in terms of Y. And that's where they get confused. Okay. If you go back and look at the plane, what's the plane doing on the blue line? It's going up. That's increasing. And then it's going to be going down. Then it's going to be going up. So the Y is only up and down. So when you're talking about the actual Y values, the Y values are going to go up or down as you travel X. And X is the dominant. And we've said that since, good gracious, how long? Since the 5th or 6th grade? Your dominant variable is the X variable. X tells Y what to do. So if your plane is going up and down, the only thing that you're worried about is where it is in relationship to the airport or the runway. The runway, if you don't have a runway, you ain't got no plane. All right, so you got to have everything in terms of X. So the plane, if you're reading from left to right, that we always do, what is my plane doing on the blue line? That's F prime of X, I believe, or is that F double prime? Which one is F prime? I'm looking. They got the blue line going through there. So can somebody tell me? Golly bum. I think the blue line is F double prime.
Yes.
Okay. The red line or the magenta line is F prime. So they're talking about find the intervals on which F is increasing and decreasing. F is decreasing on 0 to 5 and 15 to 20. Hold on just a second. Yeah, that's right. Okay, find the critical points and the inflection points of F, the intervals at which F are increasing and intervals concavity, then graph F assuming. Okay, so we know that F double prime right here, F double prime is giving us two critical values of 15 and 5. Okay, because we've got, and the transition point is -10 or +10. So with the blue line, F prime, and I'll write this down on the, hold on just a second, I'll write this down. We've got 5, 10, and 15. So if we've got on the blue line, 5, 10, and 15. Those are all critical points, critical on f double prime of x. And then on the magenta line, we've got magenta is, I don't know what point that is right there, but we've got 5, 10, and 15 again, and then 20. So 5, 10, 15, and 20 are all critical points. I can't spell, on f single prime of x. So as long as we've got increasing and decreasing values of these points, you should be able, I'm going to see because I didn't see how this question ended, they should be able, yeah. Okay, it says graph assuming f of 0 is equal to 0, choose the correct graph below. This should be the graph of the original function because it starts at 0 and ends at 20. And then where you have the 10 right here, hold on, where you have that 10 is your value of inflection right there. So this is the inflection point. And of course, these are your vertexes. I'm sorry, trying to write and do this at the same time. And your outside is your vertex, your outside is your vertex, and your middle point, that's going to be your inflection point. Okay, so that one should be pretty straightforward. Next one. Oh God, here we go with these freaking Riemann. Let me get out of this. Riemann. All right, here's a Riemann. Let's see which Riemann this one is. Okay, that's the one, and I'll set you up on this one. First of all, they say, I got this one somewhere. Hold on. Let me find it. Cosine x. Well, I don't have it. I guess I'll just set it up by hand. All right. So this one, you know it's in the first quadrant, and it's probably going to be D or B. Let's see. There it is, D. I'm going to blow that one up and make sure you draw a good picture of it because everything is based on this drawing. Okay. And it looks like you go in 4 sections, 1, 2, 3, 4. So 4 dots, and it's going like this. 1, 2, 3, 4. So it's going down, something like that. Okay, so I'm going to get rid of that one and bring in my handy dandy. That's what mine looks like. And I'm going to bring in my handy dandy ruler. I even got a ruler. 1, 2, 3, 4. So that's what we're looking like. And it says n is equal to 4. So right now, we're going to find our delta x. So that's 3 pi over 4 minus pi over 4 over 4. And that's going to equal 3 pi over 4. 2 pi over 4 divided by 4 over 1 multiplied by 1 over 4. And that comes out to be pi over 8. Somebody check my math on that, because I didn't do this problem. So that means each one of these guys is equal to pi over 8. Now, what I'm doing here is I'm doing it with a trig function. I'm doing it with f of x is equal to x squared. It doesn't matter. You got to find delta x. Delta x is each one of these spaces, and there should be 4. Because you got to set up Riemann. Okay, there's your 4 spaces. Now, each one of these, the first one starts with pi over 4. And this is 3 pi over 4. So add 2 pi over 4. Let's see. That would be, I'm trying to think of, let's see. Well, you're going to have to add pi over 8. That's going to be 2 pi over 8. That'd be 3 pi over 8 right here, correct? 3 pi over 8. And then 3 pi over 8 plus 4 pi over 8, which is pi over 2. Y'all help me out. And 3 pi over 8, that'd be 4 pi over 8, which would be, no, that's not right. Hold on a second. Pi over 4, that'd be 2 pi over 4 over 8 plus pi over 8. That'd be 3 pi over 8. 3 pi over 8 plus 4 pi over 8. Yeah, that'd be pi over 2. And 4 pi over 8, that's where I went wrong. That'd be 5 pi over 8. Okay, now I've got my spots. So I take my handy dandy highlighter and I highlight these 5 spots. Because those are going to be used in left and right. Now, I've been over Riemann probably several times. So I'm going to go over this. I'm not going to do the math, but I'm going to go over the left side again and the right side, because I doubt very seriously you're going to see this on a test. I know you're not going to see it on mine. Okay? So left. Left is going to be orange. Left is going to be here. It's going to be here. It's going to be here. And going to be here. Can anybody tell me? Well, no, this is going to be there. Sorry. Each one, I started on the left-hand side first. Okay? So how do you get this point right here? And this point, and this point, and this point. You plug in pi over 4 into your original, which you take the, let's see, what is that? The cosine. What is the, let's see, we're taking the antiderivative. What is the antiderivative of the cosine? Somebody look on your cheat sheet. What is it? Negative what?
Antiderivative of cosine would just be sine.
Is it antiderivative? Okay. So you take sine of pi over 4, and that's going to be that point. Take the sine of 3 pi over 8, that's going to be that point. And this point, and this point. And what am I going to multiply each one of those by? Because that's the height. And then multiply by the what? The width. So you're going to find this point. I'm going to call this left 1, left 2, left 3, and left 4. And you're going to take each one of those, you're going to add them up and multiply it by pi over 8. Or take each one and multiply by pi over 8 and add them all up. And that will be your left area. The right area we'll do in blue. I don't get to use this blue one much. Okay. And I'm going to go up. And that's going to go out here. Go up. Out here. go up out here and go up. Now, some of these numbers you already have, so you don't have to do it twice, okay? In this case, and I'll do this in blue, I'll do this in blue so you can see it. You're going for the right area, you're going to use this point, which you already have, L2. You're going to have this point you already have, which is L3. And you're going to have this point, which is L4. And this point, which you don't have yet, will be the sine of 3 pi over 4. And that will be right 5. And this will be right 4. This will be right 3. And this will be right 2. And that is the area for the right. And they may ask for the midpoint. The midpoint, I'm going to do it, I haven't done green yet. So the midpoint is usually the most accurate. I'm going to put a line under it, and that would be, you got to find a new point. That would be this point, and this point, and this point, and this point. And with the midpoint, you have to find a new x and a new y. And then you add them up and multiply them by pi over 8. So each one of those areas, you got to multiply by pi over 8. This first one, okay, you've got to take pi over 8 and divide by 2. So pi over 8 divided by 2, which would be 16, pi over 16. So you've got to add pi over 16. So that'd be pi over 4 plus pi over 16. And then 3 pi over 8 plus pi over 16. This is to get your midpoints. And then pi over 2 plus pi over 16. And then 5 pi over 8 plus pi over 16. And then, of course, you don't need that one. And that would give you these 4 points right here. And then take that point and plug in and multiply by, and that's how you do Riemann's. Like I say, I doubt you're going to have to worry about that one too much, except on the homework. Now, let me show you right quick. This one came, and I want to go over it just so you'll, I'm not going to do all of it. I'm just going to do 1 or 2 of it. Let's see if it's this one. I think it's this one. I don't know. This is the one with the sigma. Yeah. Okay. I'm just going to do 1 or 2 of these. These are just, you know, plug and chug. So the first one says, the summation from 1 to what? 11 of k. So what am I going to plug in for the first k?
1.
And the second?
2.
There we go. And that is how you do that one. C, that's A. I'm going to do C. C says the summation from k is equal to 1 to 8. So the first one is going to be 1 squared plus what?
2 squared plus.
And all the way up to what?
8.
8 squared. And that's going to be a number. E. I'm trying to, let's see, A, C, E. E is the summation, thank goodness for 3. The summation K equals 1 or M is equal to 1, it really don't matter what the variable is, to 3 of 3M plus 3 over 5. So I got to do 3 parentheses plus 3 over 5 plus 3 parentheses plus 3 over 5 plus 3 parentheses plus 3 over 5. And what am I going to plug in? I'm going to plug in a 1 here, a 2 here, and a 3 there. And that's going to give me 3 plus 3 is 6. So that's 6 over 5 plus 9 over 5 plus 12, right? Yeah, 12 over 5, which is equal to 12, that's 18, what, 27 over 5? Help me out there.
Yep.
And that's your answer. This is a standardized test question, but it's not one of my test questions. Let's do the last one. Summation from n is equal to 0 to 4 of the sine. I'm just going to plug and chug. I'm not going to do the calculation. And that's going to be n pi over 2. So parentheses pi over 2 plus parentheses pi over 2 plus parentheses pi over 3 plus parentheses pi over 4 and I'm sorry, over 2 and 2, sorry. And that's 0, 1, 2, 3, and then one more plus 4 pi over 2, and then calculate. Of course, this one goes out. This one you get pi over 2. Leave the denominators as is, because it's easier. 2 pi over 2 plus 3 pi over 2 plus 4 pi over 2. 4, 7, 9, 10. Now you can 10 pi over 2, which is 5 pi.
Remember, you're taking the sine.
Oh, yeah. And then take the sine. Okay, I'm sorry. Thank you. Sine, I'm sorry. I thought we were just doing.
Yeah, it comes out to 0 or 1.
Okay, forget it then. Sine, what does it come out to be?
It's either 0 or 1.
You said to the 0 or 1. What did you? I didn't catch you.
It comes out to 0 or 1. I lost track of it in my head.
Oh, you can't remember? It's 0 or 1.
No, it's just sine over the 4 points.
Yeah.
So it's either adding 0 or subtracting 1 or adding 1. So.
Well, what was the final? Do you remember what the final answer was?
No.
Okay.
But going through it, it's.
Yeah, it's either going to be 0 or 1, but I don't. That's how you do the plugging and chugging. Okay, so again, that may be a standardized question, but it won't be a question on the final. Okay. Now I went over a couple that are not going to be on the final. Let's go over one that would be on the final. And I want to go over this one because I had somebody ask a question about it on other instances. So I'm going to kill 2 birds with 1 stone. Let's see if I can find the question. I think it was Miss Hart's question. Oh, I just got out of my email. Great. I can't remember what the question that was, but maybe it's 5.3. It's the one with the parabola. That's not it. I mean, I have that one. That's not the one I want to go over. There it is. All right, this is a question I would put on the test or the final exam because it's area under the curve. And of course, in 5.3, you don't know how to do it, but you can do it now. I think they want you to do it geometrically, but I'm going to do it geometrically, and then I'm going to do it by the area under a curve, because I want to kill two birds with one stone here and talk about net area versus total area. Okay? Net area and total area. And can somebody summarize with just a few words? Net area pertains to the what? The sign. Total area pertains to the what? The area. Okay? So in this case, we have a symmetrical shape. We have a symmetrical shape, and it looks like this. And there's the, so write down f of x is equal to negative x squared plus 25. I have never seen people write 25 minus x squared. I have never seen that until this book. So I've never understood that. So I'm going to draw a BA picture, just like y'all have, right there. I'm going to blow it up right here for you. So you draw it. There it is right there. So I'm going to try to draw it best way I can. And we don't have the x-intercepts, but we're going to find them. So I think we got one there and one here. And our y-intercept is 25, but they got it on a different scale. So we'll do ours. We'll do ours over 12. So our y-intercept is just a little bit above that one. I'm trying to draw this. Now, the good thing about this is y'all got blocks. See those blocks right there? So I'm going to go ahead and take my blocks. I'm going to use geometry and say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to take this and make this a half. And I'm going to take this, well, I'm going to take this and put that right there and this right there. So that's going to be, yeah, 1, 2, 3, 4, 5, 6. Not 7. I'm going to say right at 7. I'm going to say geometrically it's close to 7 square units. And that's by geometry. Okay, 7 square units. I'm going to look at it one more time. 1, 2, 3, 4, 5, 6. This, and this is really not a whole. You could say this and this maybe a half, and this maybe a half. So that's why I say 7. Okay, now of course I'm talking 7 blocks. Now, of course, that it's more than that because each one of these blocks is 12. So that's 1 block by 12. So that's 12, 1, 2, 7 times 12. Is that correct? No, let's see. How big is this? Let's see. 2, 4, 6, 8. So that's 2 by 12. Each one is 24, right? So 24 times 7. 24 times 7, I have no idea if I'm, yeah, I think that's right. 7 times 4 is 28, bring you to 7 times, 168, around 168 square units. That's what I get just by eyeballing it. Now, again, it is symmetrical. All right, I'm going to pull this up now. It's symmetrical. Now, those of you that had questions about net area versus total area, the sign tells you direction, just like it does in physics, statics, dynamics, algebra. It tells you direction. That's what a sign tells you. So in this case, a negative sign is going to say left of the y-axis, and a positive sign is going to say right of the x-axis. Okay? So if we get an area over here, it's going to be negative, and we get an area over here, it's going to be positive. That's what net area is. So I'm going to do, we got to find our, first of all, we got to find our x-intercepts. So I'm going to grab this guy, and we're going to set equal to 0. What was it? Negative x squared plus 25 is equal to 0. Negative x squared is equal to negative 25. Divide by negative 1. Divide by negative 1. X is equal to positive negative 5. So from negative 5 to 0, we're going to do that area. And then from 0 to 5, we're going to do that area. Everybody with me?
Mm-hmm.
Okay, go ahead and do that. So I'm going to draw a little picture on the top of the next page. Just a little picture showing what we're doing. Negative 5, positive 5. And we're going to call this the left, and we're going to call this the right. So, antiderivative from negative 5 to 0 of negative x squared plus 25 dx. Because that's what we're doing. We have that little ds right there, and this width is dx, and we're going from here up to here. So that's going to give us negative x to the third over 3 plus 25x, evaluated at negative 5 and 0. Now I'm going to plug in 0 first. So that's going to give me negative 0 cubed over 3 plus 25 times 0, which all goes to what? All goes to 0. Plus, or minus, sorry, minus parentheses, because this, remember, I'm going to take my highlighter. Let's take a pink highlighter. That right there means subtraction. And that's going to be negative parentheses cubed over 3 plus 25 times parentheses, and we're going to plug in a negative 5. What's negative 5 raised to the third power? That's negative what? 125 times a negative. That's positive 125 minus, well, 25 times 5, that's 125, but you got to put it over 1. So that means 3. What's 3 times 125? 375?
Yep.
And that's going to give us 0 minus parentheses negative what? 250 over 3? Y'all help me out.
Yeah.
250 over 3. And that negative makes this a positive. So the area for that function for on the left side is 250 over 3. Y'all check my math, but we're going to do this side, and it should come out the same thing. Now, net area, you would say negative 250 over 3 because it's on the left-hand side. Okay, but very seldom are you going to be asked for the net area, especially
No, it's
in
not. It's above the x-axis.
Yeah, it's above the x-axis. I'm sorry, that would be positive.
Yeah, 500.
Okay, now if it's below the x-axis, it would be negative. I'm sorry. Okay, now let's do the next. Let's do the next one. So this is going to be from 0 to 5 of negative x squared plus 25, and we've already done this, so you can just go straight down to negative x cubed over 3 plus 25x evaluated at 0 and 5. Now we're going to put the 5 in. Minus 0, because that 0 is going to go out. And we're going to get negative 125 over 3 plus 375 over 3, and that's equal to 250 over 3. So 250 over 3. And that tells us that the area, the total area between these two, even the left-hand side or the right-hand side, the 250, that's going to be 500 over 3. The total area is 500 over 3. But on the left-hand side is 250. The net area is 250, and the right-hand side is 250 over 3. Okay, now, as Mr. O'Quinn said, when you're dealing with the x-axis, if you have something down here, then it can cancel. So that's why an odd function, usually the net area, with an odd function, the net area does what? Cancels each other out. But the total area is still the total area. I asked y'all this before. If you buy a piece of property and 50 acres is above sea level and 50 acres is below sea level, how many acres do you own? That's not rhetorical. I want somebody to answer the question.
100 acres.
You own 100 acres. Why didn't you say 0 acres? Because you can't cancel acreage out. Acreage is area, all right? If you buy 50 acres above sea level and you buy 50 acres below sea level, the below and the negative, they're just telling you where it is above sea level. What do I want from you? I want total area. I want you to be able to find the area under a curve.
Counterpoint, if I buy 50 acres and I sell 55 acres, I'm net minus 5 acres.
If you buy 50 acres and sell 55 acres, that's called you're a crook. And there have been a lot of surveyors and landowners that have done that before. And they've lost they went to jail.
Assuming I already own land and I sold.
Okay, yeah. All right. Here's one. That's the one that I did right before this one. Oh, what is 500 divided by 3? Well, I said it was around 160. What did I say? 168 units. What is 500 divided by 3?
$166.6.
Now, did y'all see that? I want to make sure y'all understood what I'm talking about. At the beginning of the problem, I told you by geometry, it's going to be around 168 units. And you said by the calculator, 500 divided by, divided by what? 3 is equal to what?
166.6, repeating.
166.6 or 167? Okay, here's one that might be on the test. I doubt it though, but might be on the test. This one right here. 5.342 / I want to show you one more after this one, but x to the third. I want to do x to the third and show you. All right, this one is a test question. And the first thing that you need to ask yourself here is the radical And 1 minus x squared should be a little flag that goes up, and your little flag should be saying what? Trig. Okay. When you see that 1 minus x squared, you're going to, in the future, you should say, this has got something to do with trig. And it does. Because that function is a inverse sine function. Okay, the question asks, what is the antiderivative from 0 to the square root of 3 over 2 of 9 dx over square root of 1 minus x squared? And of course, you know that this is going to have something. First of all, pull the 9 out. I'm going to pull that 9 out. 0 to the square root of 3 over 2. And I'm going to do 1 over 1 minus x squared, and then dx. Now, that's just standard. That's the way people do it. And then, of course, right now, you're saying to yourself, and I'm going to put this in red, the antiderivative of dx over the square root of a squared minus x squared is equal to the inverse sine of x over a plus c. Now that's on that cheat sheet that I gave y'all. I did the inverse sine, inverse cosine, and inverse tangent, I think. I don't know if I put all of them on there, but I know I at least put the first 3. So I'm going to rewrite this in terms of squares. I'm going to rewrite this in terms of squares. So I'm going to rewrite this, and it's going to be 9 antiderivative of 0 square root of 3 over 2 of 1 over 1 squared minus x squared dx. And here, my a is equal to 1, and my b is equal to x, or my x right here is equal to x. I wish they would use a different letter, but now I just plug x right there and 1 right there, and then plug and chug. So the antiderivative of this function is 9 inverse sine of x evaluated at 0 and square root of 3 over 2. And you're going to punch that in your calculator, and that's the setup. Now I get 3 pi. Put 3 dots here, 3 pi. I did that one. Here's one that you might see on the test. Okay, let's see if I can find this one. This one's got a number on it. Okay, I did that one and that one. This one is 5.58/3. 5.58/3. I don't see, there it is. Okay, this is a test question. Now, before you start to say you can't do it, first of all, pull that -12 out. Okay, pull it out. Or move it because you're going to use substitution. So this is where I tell you, if you've got something in there, put it with the dx, because you know you're going to use substitution here because the directions tell you to. So I'm going to rewrite mine, and I'm going to rewrite it not absolute value, antiderivative sine of 6x squared minus 7 blank negative 12 dx and a blank there. Remember me telling you, when you're using substitution, I put blanks right here because I have no idea what I'm going to need to make this work until after the fact. So u is equal to 6x squared minus 7. du is equal to 12x dx. What do I need? I need 12x dx. What do I have? What do I have right here? Anybody?
Negative.
I have a negative 12. So I don't have a positive 12, so I got to multiply through by what? A negative 1. So if I multiply here by negative 1, I got to multiply here by negative 1. Now, some people say, well, here, why don't you pull out the negative? That's fine. You can do that too. I don't care. The main thing is that there's going to be a negative out here when you get through. Now I have...
Being pedantic, you're missing an x.
I'm sorry, what?
After 12, you're missing an x.
There's supposed to be a 12x there.
Right.
Did I not?
You have a
Did I
12.
not write the problem down right?
No.
Oh, sorry. Hold on. Thank you. There's 12x there. Thank you. 12x dx. There we go. Okay, there's a 12x there anyway to begin with. All right. So now I've got negative. And what is, I'm going to rewrite this. And do we have anything? We're not, this is an infinite. So negative antiderivative of the sine of u du. And the derivative of the sine is the negative cosine. The antiderivative of the sine is the negative. Somebody check me on that. So that's going to be negative bracket negative cosine of u. And the negative becomes cosine of u. And u is equal to 6x squared minus 7. So that's going to be cosine 6x squared minus 7 plus c. Now, why would I put this on a test? Because it's substitution and it's pretty what? It's pretty simple. And that leaves me with, hold on just a second. Yeah, there's some long ones, and I'm not doing these long ones. I'm not, because I wouldn't put them on a test. This one is pretty. I'm thinking whether I need to do this one. I'm going to go ahead and go to the end and do some of those that y'all sent about area or volume. Let's see. I think this is 16318, and this will be the last one today. Okay, this is one like we did yesterday, or the ones I showed you. We're going to do the volume. Let R be the region bounded by the following curves, but they're going from 0 to 5 halves. And the derivative, or the function y is equal to negative 2x plus 5 dx. So I'm going to take I'm going to multiply the volume is equal to pi times the antiderivative of something squared dx. And that negative 2x plus 5 is going to go there. You could use substitution, or you could do algebraic. Somebody want to say what they would do?
Algebraic.
I kind of figured y'all would say algebraic. This is shortcut number what? Number 1. So that's going to be V is equal to pi times the antiderivative of 4x squared minus, help me out, 20x plus 25 dx.
Yep.
And that's going to be from 0 to, they tell you what to go to, 5 halves. 0 to 5 halves. 0 to 5 halves. So that's going to be 4x to the third over 3 minus 20x squared over 2 plus 25x over 1, evaluated at 0 and 5 halves, and multiplied through by pi. Now, of course, the 0 is going to conk everything out. So you can put x to the 0. And now you can, if you want to cancel this out, that's fine. It's not really going to help you because you're going to have to get a common denominator. So, you know, you do what you want to. Let's cancel that out and put a 10. So V is equal to pi 4 times 5 halves cubed over 3 minus 10 5 halves squared plus 250, plus 25 times 5 over 2.
Just an odd point, this one's on the test.
It is?
Yeah.
Well, it could be because I do pull questions, so it could be on your test. All right, so V is equal to pi, brackets, 4, and that's going to be 125 over 8 over 3 minus 10 times 25 over 4. And I've not done this problem, so I'm doing everything out by hand. And that's going to give us V is equal to pi. That 4 and that 8 is going to cancel. And that's going to be 125. That'd be 125 over 12, but check me. That's minus, right. That's going to cancel 5 and 2. 125 over 2 plus 5 quarters is $1.25 over 2.
Oh, wait, no, it's 125 over 6.
Where's over 6? Where's 6? Where?
You're taking the 4s out, so that leaves 125 over 2 times 3. The first term.
Oh, yeah, that's right. It'd be 125. No, that's a 4. One times. If I multiply by 1 over 3, 3 times 4 is 12.
Right, but you're taking 4 out of it, so you're leaving 2 behind.
That'd be 2. Thank you. Appreciate that. Okay, and these two do what? They cancel. It looks like they cancel. Gotta hope they do.
They do.
And that will be pi. That'd be 125 pi over 6. And I don't think that's reducible, but it could be.
25. No, that's right.
There you go. And if you do make a mistake, it's going to be probably in this area, not the calculus. It's going to be like just like I made that mistake. I said 4 and 8 will cancel. 4 and 8 don't cancel. 4, 8 cancels with a 2. Sorry about that. All righty. So that's 4. That's it's close to 426, 427. I guess it'll be happy trails, and y'all will go into Calc 2 next semester, right?
Not next semester. Forget that. I ain't doing it at Clemson.
Oh, you're done? You're done with math?
Oh no, but I'm not doing it at Clemson.
I'm not doing it right now.
I'm trying to share something with you guys, and I don't know how to do it. Here, I'll just read it to you. Do you want me to read it to you?
You go to where are you trying to share it?
I'm trying to share it in the chat, but it's on my phone, so I don't know how to do it.
You talking about the email?
I don't know either.
Yeah, the email from Clemson. Let me read it to you guys.
Okay.
As a result, today I'm announcing Clemson University will begin the fall semester online and will delay in-person instruction until September 21st. The semester will begin as scheduled on August 19th with online instruction. No other changes to the academic calendar will be made at this time. So, just a heads up, you Tri-County people, you'll probably
That
That is
means
the stupidest thing I've
Tri-County
heard all
Tech
day.
is going to go online too.
Yep.
That means
Really?
Tri-County is going to start online.
It'll be real fun taking chemistry online.
It is.
Well, do the best you can.
Oh,
Hey,
I'm taking organic online.
oh my gosh.
Yeah.
Knock yourself out there, bud. Well, listen, if nobody has any more questions, I will stay late for those, but I want anybody that wants to go, let me go ahead and get the roll. I'm going to cut this off, and I will stay for questions, and we can get down. But I'll be honest with you, though. Hold on. Stop recording. And let me get the roll.